Alright, this is Math 111 OLC Unit 1. This is the Section 1.5 video lecture entitled Solving Linear Equations. And this is our second of 3 video lectures contained in Unit 1. So let me write this down. This is video lecture number 2 of 3 that are contained in this unit. Alright, solving linear equations. Well, you know all about solving linear equations. So we're going to assume that you've been looking at this stuff more or less since 7th grade. And, well, let's start out nice and easy. How do I solve this linear equation, 2x minus 8 equals 0? Well, of course, we do algebra type things. We add, subtract, multiply, and divide to isolate, get the variable on one side of the equation and a numerical value on the other, thus solving the equation. Alright, I'm sure we all know how to do this. We will add 8 to both sides, so get 2x equals 8, and divide both sides by 2, and get the result x equals 8 over 2, which of course simplifies to 4. Alright, so I'm not going to insult you by running through something that simple again. Let's kind of go up the line here a little bit. Alright, let's try 3a plus 15 equals 0. Again, we will try to isolate the term involving a, our unknown, first, then divide both sides by the coefficient of a, namely positive 3. So 3 over 3, of course the 3's cancel out, reduces to a, and minus 15 over 3 reduces to a negative 5, right? So your return there is negative 5. Alright, let's go up the ladder a little bit. How about equations with fractions? Now, students sometimes tend to fall apart here. Well, let's just stay with it. You've got an equation that involves fractions, and the first thing I'm going to do is get rid of the fraction. How am I going to get rid of the fraction? I just can't erase it. What I'm going to do is multiply both sides by the least common multiple of all the fractions. Well, we've only got one fraction here, so all I have to do is to get rid of the fractions is multiply by 4. The 4's cross-cancel now on the left. I get 3y equals minus 28. Now what do I do? Well, you've got to solve for y, not 3y. I'll divide both sides by 3. Simplify if I can. The 3's cancel out on the left. I get y equals minus 28 thirds. Now 28 is not a multiple of 3. 28 is 7 times 4. So there's no way to reduce this. We just keep this in improper fraction form. Oh, please, no mixed numbers. That. Hang on a minute. At this level and above, we kind of assume that mixed numbers have lost their charm. And a number of reasons for that, which I won't go into here. So please do not give your answers as mixed numbers. Improper fractions are just fine. Improper meaning the numerator is typically of greater magnitude than the denominator. Alright, let's try another one like this with fractions. Again, here's where students start to go south in these types of problems. 2/3 b minus 3 equals minus 15. What do I do about the fraction? Get rid of it. How do I get rid of it? Multiply all sides, both terms, by the least common multiple of all fractions contained in the equation. Well, there's only one fraction here, and the only denominator there is 3. So if I multiply both sides by 3, the fractions should go away. And of course, I can add or subtract, multiply or divide both sides by anything that's to my advantage to isolating the unknown variable. Alright, well, the thing is you've got a subtraction here, right? You've got to apply your distributive law, so I have to multiply both of these terms by 3 on the left. Alright, 3 times 2/3 b is going to be, well, the 3's cancel out, and I've got just then 2b, no fraction, minus 3 times 3 now is 9, and on the right, 3 times minus 15 is minus 45. So it looks better already. Again, we want to solve for b here, so I will then add 9 to both sides. All right, leaving 2b on the left, and minus 45 plus 9 is negative 36. Okay. And then I'll divide both sides by 2. And minus, well, let me go ahead and write that out. Minus 2, divide both sides by 2. The 2's cancel out on the left, and I get b equals negative 18. So b equals negative 18 is the return for that fractional equation. Okay? Fairly familiar stuff, I hope. Let's go on. Let's try another one here. How about minus 6x? Let me show you to copy this right. Plus 6x equals 1 plus 2x minus 5. Alright, I think what the author is trying to do, I grabbed this one, I read it out of the book, by the way. I think what the author is trying to do here is to keep you from doing unnecessary work. Right away, I see that minus 6 and plus 6 on the on the left-hand side will cancel each other out. So I always look to simplify within each side first before crossing over the equality sign with additions, multiplications, etc. Alright, so what I'm going to do is claim, well, and on this side, the minus 6x plus the 6x cancel out. I get minus 16 on the left. 1 minus 5 is negative 4. So I reduce the expression to minus 4 plus 2x on the right. So I'll get 2x, let's see. I'll leave 2x on the right, and I suppose I can add 4. If I'm going to do that, I'll add 4 to both sides. I get 2x on the right equals minus 16 plus 4 is minus 12 on the left. Now divide both sides by positive 2. And 2x over 2 is just x. The 2's cancel out, and I get x. And minus 12 over 2 is minus 6. So I get the correct return, x equals minus 6 for that problem. Alright. And again, let's go up the ladder little by little. 7 times a minus 2 equals 8. And typically on test day, leave this instruction, solve the following equations. Alright, well, the idea here is I've got a buried in a subtraction tangled up with a multiplication on the outside. Well, if we're going to isolate a, the first thing we've got to do is get rid of these parentheses. In other words, multiply this inner expression here by positive 7. Again, you've got to apply your distributive law, as you probably know. 7 times a is 7a, minus 7 times 2 is 14, equals 8. If I now add 14 to both sides, I get 7a equals 22. 14 plus 8 is 22. And a equals 22 over 7. Now, 22 is not a multiple of 7. 7 is prime, and 22 contains no factors, no multiples of 7. So I'll leave my answer just like this, reduced. Answer in simplest form. Note this is in simplest form, and all your answers, especially your fractional answers, should always be expressed in simplest form. No mixed numbers, please. Improper fractions are just fine if the numerator is greater than the denominator. Alright? Alright, let's do some of these tougher ones now. Give me a minute here. How about alright, we've got d minus 3 times d minus 7 equals 2 times 4d plus 10. Alright, let me go ahead and grind this out. Again, we've got variables on both sides of the equation. We're going to have to combine like terms, crunch things together, get the variable on one side of the equation. Of course, I'm going to have to get rid of these product type expressions by applying my distributive law. And I'll do that right now to free these terms up for combining into like terms. Alright, negative 3 times d is minus 3d. Minus 3 times minus 7 is positive 21. Alright, so that simplifies the expression on the left. How about on the right? 2 times 4d is 8d plus 2 times 10 is 20. Alright, again, I like to combine within sides before I start crossing over the equality symbol. D minus 3D is, of course, minus 2D plus 21 equals 8D plus 20. That's a 20 there, right? Alright, what am I going to do now? Well, I suppose I could try to get my variable on the left or the right here. It really doesn't matter. I suppose you should be able to do it either way. I'm going to add 2D to both sides, ending up with my D variable expression on the right-hand side. If you're going to do that, whoops, I slipped. Hang on a minute, don't panic. Right. If you're going to do that, you would probably then subtract 21 from both sides. I'm sorry, subtract 20 from both sides. Alright, so now combining these like terms, I get a positive 1 on the left and a 10D on the right. Okay? Again, the goal is to solve for D, so I'll divide both sides by 10. And the 10's cancel out on the right, and I get D equals 1/10. Okay, so that's your correct return for that problem. Alright, let me get a fresh screen here. We'll go on and do some harder ones. Alright, here we go. How about something that looks... Let's do another one somewhat similar to the one we did before, just now. 1 minus 3h equals minus 2 times 5h plus 25. Alright, let's take a look. Make sure I copy this right. 10 times h minus 1 minus 3h equals minus 2 times 5h plus 24. Right here, we've got nested sets of parentheses on the left. And again, another product, a variable involved in a product, and a sum on the right. Well, basically, I'm going to start on the left and work from the inside out. Alright, I'm going to perform this negation, really, multiplying this expression, this parentheses expression by minus 1. I get a negative 1 plus 3h, carrying that negative sign through the innermost set of parentheses on the left-hand side, leaving all other operations pending. Okay? Alright. Of course, now I'll simplify within these brackets. H plus 3h is 4h. So that bracket expression really turns into a 4h minus 1. All right. Now I'm going to have to perform these multiplications to free up my variables from the parentheses in which they're trapped. I'll get 40h minus 10 equals minus 10h plus minus 50. Well, let me be sure about this. Minus 2, applying my distributive law, minus 2 times 5h is minus 10h. And now minus 2 times 25 is minus 50. So I can write it like that. I think most students at this point would add 10h to both sides. And if you're going to do that, your h will be on the left, so I want to add 10 to both sides to get my numerical value on the right. I get 50h equals then minus 40. All right. So now dividing both sides by 50, I get the 50s cancel out, and I get h equals minus 40 over 50, which of course reduces to negative 4/5. Alright. Let's see how much of a screen we got left here. I think we've got enough. There's a couple more nastier ones I want to talk about before we end this video lecture. Solve the following equation. Now, what happens here, this is one students tend to do badly on, so listen up out there. My first goal in this problem is to get rid of the fractions. I don't want to be adding, subtracting, multiplying, dividing fractions. I don't think you do either. So I can get rid of the fractions if I multiply by the magic number, and the magic number is 12. How do I know it's 12? Because 12 is the least common multiple of all these denominators. Notice 12, 4, and 3. 12 is a multiple of them all. Okay? That's why they call it a common multiple. All right, so I'm going to multiply both sides by 12. And the trouble is, on the right-hand side, you've got a sum. On the left side, you've got really a string of products. Now, I can apply my distributive law, my commutative law here, and multiply 12 times a third first. All right, and that'll get a whole number out of that. 12 times 1/3 is, of course, 4. And I'll leave this remaining operation pending for now. Now, if I multiply this expression on the right by 12, I've got an addition. You've got to distribute this 12, multiply both of these items, let me circle them, independently by 12. That's not a 2 there, that's a 12. The circle covered off the 1. All right, 12 times 5/4. What's 12 times 5/4 x? Well, let me cross cancel first. The whole idea is to get this denominator to cancel out with something in your LCM. 4 goes into 12 3 times, so 3 times 5x is 15x. Beautiful. No fraction anymore. Well, 31 twelfths times 12. Well, of course, the 12s cross cancel, and I get 15x plus 31 on the right. All right, so it looks very much better than it looked before. Let me go ahead and perform this multiplication now on the left. I'll get 8x minus 4. Check that. 8x minus 4 equals 15x plus 31. All right, what am I going to do here? I suppose I might subtract 15x from both sides. That way my x variable will end up on the left. I'll then add 4 to both sides. All right, 8x minus 15x is minus 7x equals, well, 31 plus 4 is going to be 35. All right, now I'll divide both sides by negative 7. If I can center this frame. And negative 7x over negative 7 is x. The minus 7's cancel out. And 35 over minus 7 is, of course, minus 5. So x equals minus 5 is the correct solution for that expression, or that equation. All right. Let's see. What next? How about this? Solve. Solve the following equation. X plus 2 over 5 minus 4x equals 8 over 5 minus x plus 9 over 2. And this pretty much represents the upper limit of difficulty for this section. Let's see. My first step is get rid of the fractions. How do I get rid of the fractions? You multiply by the LCM. Well, what's the LCM of these three denominators? We've got 5 and 5 and 5. Of course, the LCM equals 10. All right, so I'm going to multiply both sides of this equation by 10. But you got to be careful, because there are some expressions within expressions here. As you know, on the left, you're going to have to apply your distributive law. All right? You're going to have to multiply both of these expressions by 10 independently and then subtract the result. All right, to do that, well, for this first product, I'm going to say 5. I'm going to cross cancel. 5 cross cancels into 10 twice, and I'll have 2 times x plus 2. Takes care of that product. Now I'm going to multiply 10 times 4x. Minus 10 times 4x is going to be a minus 40x. Numbers are getting a little nasty here, but don't panic. How about on the right-hand side? Well, similarly, you've got 2 expressions. Okay? You're going to multiply this side by 10, so you've got to multiply both of them by 10 independently, illustrating your distributive law. Alright, my goal is to get rid of these fractions, so let's cross cancel. 5 goes into twice, and 2 times 8 is 16. A number. Minus. How about for this right-hand expression? 2 goes into 10 5 times, and I get 5 times x plus 9. I'll write it just like this. I'm having a little trouble here. Minus 5 times x plus 9. Alright, now that was a bit of work, but the fractions have gone away. Now I'll go ahead and multiply. On the left hand side, 2x plus 2 is going to be 2x plus 4 minus 40x equals 16. On the right hand side, minus 5 times x is minus 5x, and minus 5 times 9 is minus 45. So now I've freed up my variables and number expressions to be combined. Alright, I'll get minus 38x plus 4, combining like terms on the left, and minus 5x. What's minus 45 plus 16? 55, is it minus 29? Let me check it. 45 minus 16. Let's see, 45 minus 10 is 55. Oh, I'm sorry, 45 minus 10 is 35. 35 minus 6 is minus 29. Alright, looks okay to me. Alright, on we go. What do you want to do? Well, I suppose some might add 5x to both sides. If you're going to do that, then you would probably subtract 4 from both sides. So minus 38x plus 5x is minus 33x. On the left, everything else cancels out on the left. On the right, minus 29 minus 4 is, guess what, minus 33. Oh, that looks convenient. I suppose things were rigged to happen that way. I'll divide both sides by minus 33. 33's cancel on the left. I get x equals, and of course, negative 33 over negative 33 reduces to positive 1. Okay? Alright, so that is the selection of problems I chose to present to you in Section 1.5 in Unit 1 of Math 111 OLC for winter 2012. Again, please be sure to do all the homework before the online exam 1. And since we've got 3 video lectures, do all homework and view the videos. Write that down, and view all the video lectures, because we've got 3 of them for this exam, before the online exam. Right? Oh, come on. Hang on a minute. Alright. Alright, do all homework and view the 3 video lectures, namely 1.3, 1.5, and 1.7, before the online exam, before attempting your online exam. Alright, so we're reaching the 24-minute point, so we're going to call it a day for Unit 1, Video Lecture 1.5, Solving Linear Equations. This is the second of 3 video lectures for this first unit. That is all.